Hello everyone, welcome to my channel Data Doctors. I am a senior data scientist working for a very big cybersecurity company, and I carry extensive experience in building machine learning and data science related solutions. So I started this channel some time back to share my knowledge about data science and machine learning. And there are multiple playlists in development. So one of them is about the data science related interview. I took a lot of interviews, and I have a good experience in interviews. So I would be sharing interview questions and their solution as part of separate playlist. But today I thought maybe I'll try to code, kind of do live code, a very simple multi-class classification problem. So it is like kind of ABC of machine learning. So with that note, let's jump in the coding. So what's the problem I'm trying to solve today? So I data set called MNIST. So you might be aware about this MNIST. If not, then let's go to Wikipedia and try to see what exactly is this. This is nothing but database, and I'm sorry. So, which is collected by National Institute of Standard and Technology. So, it has around 70,000 of records, and basically, it's an image of digits between 0 to 9. So there are, you can think in terms of machine learning or data science problem, that there are two columns. The first column is image, and another column is the label. So as you can see here, so 0 0 and 1 1. So this kind of 0 to 9 will be the target variable, and which is nothing but label in other terms, and the image which was handwritten would be the features. So image here is like 28 by 28 pixel, and total number of data total number of the size of data is around 60,000 training examples and around 10,000 testing examples. So with this note, so let's try to jump into our collab notebook, which I spin up and here in Google Colab. So what I will try to do is I'll try to import this data set and do some basic processing. I'm like this is the beginner, the first step. I think you can say that machine learning 101, wherein I will not go anything in depth. I'll just show you how to import the data set and then train a neural network, very simple neural network, and try to visualize how the prediction would look like. With that note, let's jump into coding. So to begin with, let me load the library load the library. So one of the important library is numpy. So import numpy as np, and import matplotlib matplotlib.pyplot as plt. And the first one is to convert the images into numpy array. Another one is, this is for plotting. So another one which I want is import from sklearn dot datasets. So sklearn is a big kind of hub wherein we have this datasets, and you can import from the dataset fetch open ml. So this is a function to fetch the data. So for now I will try to just import these libraries. So these libraries are imported now. Let me try to load the data set. Load the data set, which is nothing but MNIST. So how do we do it? So you see here, fetch open ml is a function. So fetch open ml. So let me try to see what kind of variable it takes. So you can see the name. So what is the name of the dataset? So name of the dataset is MNIST and 784, because image size is 28 by 28 pixel. So 28 into 28 would be 784. So this is the name. And another thing you can see here, it is version. So version 1 I want version 1, And let me see if we want something else as well. Okay, yeah, I want this return x and y argument to be true. Return x and y argument to be true. Why? Because I want x, which is feature, and y, which is labels or target, you can say. I want the data in this kind of format. So this is why I did this. Let me try to run this cell. Okay, I think it is giving some kind of error. So what's the error? Explain error. So what does it say? Coded version. Okay, SION. I'm sorry about that. Now we have this dataset is being loaded. So dataset is being loaded. So meanwhile, what I'll do is I'll try to uh, uh, segregate this dataset into testing and training. So to do that, right? So split dataset into train and testing data. So let me try to split features first. So features is nothing but xtrain. I'll name it xtrain and xtest. It's like kind of right, 60,000 records are there. If you add the test set as well, so it is kind of 70,000. So first 60,000 would be xtrain, another 10,000 would be xtest. So what I'm doing here is segregating xtrain and xtest. So from 0 till 60,000, manually I'm trying to type it here. I will keep it as xtrain, and xtest I will keep it from 60,000 onwards. So this is about xtrain and xtest. Like I splitted the features, all the images, and into two groups. The first 60,000 would fall into training and another 10,000 would fall into testing. So this segregation is done. Now let's try to segregate the labels. So y train and y test. So likewise, from 0 to 60,000, all the rows will have that label in y train, and after that, after 60,000, so y test y 60,000. Let me try to modify this. So from 60,000 onwards, all the labels will be part of this y test, and for 60,000 would be all the labels would be y train. So let me run this. Yes, you can see that it ran successfully, and now I was able to split the data set into training and testing. Now what is remaining? The remaining is all these images, right? So images are right now in form of some kind of pixels. So I need to do kind of scale the images. So scaling the images. Why I need to scale? Because the pixel values might be from 0 to 255. So if I try to normalize that, it would be better. Scale the images and convert the dataset into NumPy arrays. NumPy arrays are fast in computations. That's the reason I'll be trying to converting. I will try to convert the data into NumPy array. So I can do this in single step. So what you can do is xtrain and xtest is equal to, now first thing is scaling. So xtrain, I'll just divide it by 255, because any image can have pixel values from 0 to 255. So this scaling is done. Now I'll just try to call np.array on top of this, and this will give me a numpy array, and the pixels are normalized. So likewise I will do this for test data set as well. So x test divided by 255. So this is done. Now same thing I should do with labels or target variable. So and y test. So np dot array and np dot array. So what is that? Y train. But here this is just a label, it's not an image. So it does not, so in this case I don't even have to normalize it. So what I can do is I can convert it into d type. Data type is equal to np dot int 8. So I just convert into some kind of integer. So let me copy this, and here in place of y train it would be y test, and d type would be this. So in this step what I did, I normalized the training set and I normalized the test data, and after that I just converted these training labels and testing labels into integer. Perfect. So you can see it ran successfully. Now I want to see how the data looks like. So how the data looks like, how would you see? There can be there are methods to visualize it. That's the reason I have imported this matplotlib pyplot, right? So let me try to visualize few image. So to do that I'll call this plt dot figure to give me the kind of a skeleton of figure. So it has a parameter called fig size. Fig size you can keep it anything, like let me keep it 20 and comma maybe 5. So this will give me some kind of canvas. So our canvas is ready. Now I need to add some figures. So these are nothing but images. So let me try to plot first four images from training data set. Okay, so my canvas is ready, like figure canvas is ready. Now what I will do, I will try to write a for loop for index, and there is a data set. So you just visualize it in a way that there is a data set, and the rows are nothing but these images, and the column which is in the column in the another column, like first column we have images, nothing but features, around 784 of them, and another column which is nothing but target column, there we have labels. So I want to index the image and grab that image and display it, and at the same time I want to display the labels as well. So to do that, how would I do? So image comma label, and this in enumerate, I'll enumerate this, and I'll try to zip it x train. I'm trying to plot the training data, right? So I have x train, and how many images? First four images, 0 to 4. I'll try to zip it this first four images with their labels. So x train, and it has label 0 to 4. So I just combine this images with the label, and I'm trying to index every of these rows. Like in one row there will be one image and one label associated with that. So that's the now once I have this, now I'll try to create a subplot. So plt dot subplot function I should call, and sorry, so in the subplot function okay, I just wanted to see what are the options in subplot functions, what are the arguments. So I think let me plt dot subplot. Okay, so you can see here now, first is n rows, number of rows, number of columns. So I have I want to display only 4 images. So number of and all the images I want to put it in one row. So number of rows would be 1, number of column would be number of column would be 4 images are there. There will be 4 columns, and index starts here in enumerate from 0. So I will try to put it index plus 1, because in the first iteration the first image would be picked from here. So I have got this subplot as well. So basic skeleton for plotting the image is ready. Now I have to take out those pixels and put it, convert it into image and put it here. So how would I do? So there is a function called plt.imshow. So which is imshow is nothing but image show. So in the imshow, what will I do? Now I will try to grab that image. So this is nothing but here. Just imagine that this is first loop. So first image from here, and it will grab that image, all those pixels, and it will reshape it. It will reshape it in form of what? It will reshape it in form of 28 by 28. Now I have got it reshaped. So okay, I think the spelling for reshape is wrong. SHAP reshape. I reshape these images like this. Okay, now I want only gray image. So there is parameter called color map, nothing but cmap, and cmap is part of plt cm dot I just want gray images. So this is how I can put. So image I have embedded it. Now I'll try to add the title. So title I can add anything. I can add title like the label. Maybe I'll just say label is nothing but, here I have this label, right? So I can just use that variable. So this is the label. So let me try to run this. So it is taking some time, but here you go. You see the first image, it says that label is 5, and you can see from the image that it looks like 5, and second image 0, and third image is like label 4, and it looks like label 4, and fourth image. Perfect. So these are true labels. So this is training data. These are true labels, and we have not done any prediction yet. So the labels whichever is being seen here is pretty that's the true level in the data set. So now we visualize the data already. So let's try to train a model. So to train a model, we need some kind of algorithm, right? So today I'm going to use an algorithm from scikit-learn library, scikit-learn and neural network. From scikit-learn neural network, because it is kind of multi-class classification, so I'm not using the other traditional machine learning like any classifier, logistic regression, SVM, so those kind of algorithms, and this is for quick demo purpose, and neural networks are usually a bit faster, so that's the reason I picked this neural network. And now you can import MLP classifier. MLP is nothing but multi-layer perceptron, and this is classifier. I just imported it from here. So let me try to initialize that. Initialize it. How would I do that? MLP classifier. Let me see what kind of parameters it takes. So you can see the first thing is hidden layer size. How many hidden layer, like what kind of input size you will be giving to hidden layer. You can put any number here. You have activations, what kind of activation you want to use, and lot of different parameters you can explore. Learning rate and other things are there. So let me try to see what kind of parameter I would be interested in using. So let me try to use hidden layer size, and I'll just keep it 50. Now another parameter, solver. So let me try to use solver as SGD, stochastic gradient descent, SGD. Now another parameter, anything I can set. but since the training may take some like time, so let me try to use this max iter parameter. So I don't want to wait too long, so maybe let's try to train this model for just 10 iterations, and let me try to make verbose is equal to 10, because this will um, show me as the training happens what is the training and validation loss. So this I need to initialize it right into some variable. So let me call this variable mlp, or maybe hwd, handwritten digit and classifier. So this way I have now to train this hwd classifier, you just call a fit method on this, and because you will be training your model with your training data, right? So this is like xtrain, and training data, what is the label of your training data? So it would be y train. Perfect. Now in some time you would be seeing that the training would start here. So you see, in the first iteration started and the loss is pretty high, and with each iteration the loss is going down. So I have ran it only for 10 iterations, so you might not see a lot of decrease in loss, but still the model would be pretty decent. So let's wait for some time and let's see. So okay, perfect. So I have got a model in uh, 10 iterations, and you know this is just basic, right? So while trying to solve a real life problem, you would play with lot of hyperparameters and parameters, and this is just for demo purpose. So you can see a nice explanation of this model as well is there, whatever I have used as parameters. So this explanation is there. So I have a trained model. Now I wanted to see the accuracy of this model on this data on which it was trained and on the test data as well. So let me print it. So print training accuracy is, so training accuracy is nothing but now hwd classifier dot, I'll call a score method on this, and I'll pass xtrain and ytrain, and maybe I would like to, yeah, and the similar thing goes for test dataset as well. So here I'll just put test accuracy, and in place of training data I'll just put testing data. So let me see how it looks like. Perfect. So you see more or less no, this is quite strange that test accuracy it shows it a bit more than training accuracy, a bit more, but more or less like this is fine. So I have got the test accuracy and training accuracy, and now let me try to get the prediction from this model. Though this model looks good and it has not been trained much, but it looks good. So let me try to get the prediction. Ypred is equal to, so hwd handwritten digit classifier dot, I'll call predict function. So predict function I called, and in the predict function what you will be passing the test data, right? So test, so I have the predictions. Now I have this predictions for in the test data almost 10,000 samples, and I have the predictions for them from this basic model. So what I'll try to do is, let me try to plot again the similar kind of plot with the labels for prediction and the uh, predictions and the true label. So basically plot the images with true label and predicted labels. So let me grab this piece of code, so which would be pretty to just fast track it, otherwise it might take some time. So let me try to modify this a bit. I think this size looks good. So okay, Now index is fine, image is fine. Now let me try to relabel it as true label. True label because it was originally there in the dataset. Now another variable I would add is predicted label, what our model has predicted here. And in this data, and here also, here as well, let me try to put it only plot only 4 images. So here, but we have taken the prediction or test data set. So here we need to modify train to x test and y test. Perfect. And now I need to, because I have now image and their true label, what I need the predicted labels, right? So y red and the labels 0 to 4, all 4 rows predictions. And I zipped it and everything got zipped. First is image, second is true label, and third is kind of its prediction. So suppose you can visualize it in a way that okay, there is an excel format, in excel format, as if like there are 3 columns. First is image, another is true label, and a third one is the predicted label. And likewise I have labeled it here. So this part remains same because only 4 images are there, and this part also remains same because only 1 image is there, and this remains same. Now let me try to format the title a bit. So okay, here in place of label I will put true labels, and I will display this. And now let me try to take a new line and just below true labels, and it should show predicted label, predicted label, and predicted label would be this. And maybe what I can do is, let me try to use a font color. If the prediction does not match, then I will try to show that as red, something like that. So maybe font color, so here let it be green if true label is equal to predicted label, else let it be red. And I will try to use this in title function. We have this option to set font color, right? So I think the argument is color, so in color you can just use the font color. And now what I want is, okay, I think this is good enough. So let's see if we can see some test data set along with the true and predicted labels. Perfect. You can see our model has done pretty well for the first 4 images in the test data set, and the accuracy seems to be 100% because you can see here true label was 7 and it looks like 7 as well from our eyes, and predicted label matched whatever the true label is. So all of them. Okay, so this is like too much of accuracy, and but if you see the stats, our model is only 90% accurate. So there might be some images where the prediction is not aligned with the true label. So what to do? So let me try to maybe plot more images. I will try to put first 12 images, and we have 12 images. So to plot the 12 images in 2 rows, or maybe let me try to put it in 3 rows, and 3 rows and 4 columns. So this should be fine. So I just modified this. This was 1 row. So in 1 row I was plotting 4 images. So if I want to plot around 12 images, then it should be like 3 rows. So let me run this. So let's see. Maybe let's wait a while because this is an image, and so okay. it's quite yeah, we can see some image which is quite dirty, some image where the prediction is wrong basically. So maybe the images are very small. So let me try to plt dot axis. Let me try to turn off the axis, and this was 20 into 5. So maybe let me make it into 2020, a bit bigger size. So okay, yes, now you can see. Now you can see for the first row all the four images prediction true label is matching with the predicted label, and for second row as well. But here is the catch. So this is the one, true label is 5, and with human eyes also you can see that it looks more or less kind of 5 and 6. Even we will get confused, but that's why I think our model got a bit confused and true level from the dataset, because it is handwritten note. So someone would be writing like this 5, and actually true level is 5, and our model was, from the training it figured out that it might be 6. So if I have to see the probability as well, I think probabilities would not be that high uh, for 5, oh, like for 6. So you can see out of 12 images only one image is there wherein our model went wrong. So that's all I wanted to show today, and to summarize it is like I picked a MNIST dataset from outside, and I just loaded the dataset, and I did not do much of pre-processing or something, just the scaling to normalize it in between 0 to 255, and converted this into array because wanted to make the computation fast, and stored some images here, and trained a very basic MLP. And there are a lot of optimizations. If you really work in real time data and real world problem, it won't be this easy, but at least it is. These are the steps you need to follow if you want to solve or any machine learning problem. With that, thank you very much for watching my video, and happy learning. Thank you.